Hey everybody! The purpose of this little video is to give you a couple solutions to the golden ratio quiz. A couple of them are internet research type of things where you have to go online and find some results. So it might not be as complete as some of the other solutions that I make for some of the quizzes. Sorry about that. But I'll give you a few anyway. The first one, it tells you that the value of phi, root 5 plus 1 over 2. And then it asks you what's the approximate value if you have 3 decimals. You just run that through your TI, it's about 1.618. 1.6 if you go to 2. That's a pretty useful number in and of itself. I like it. I like 1.6 only because that itself is a fairly, it's close to a bunch of fractions. If you think about it, it's close to 5/3, which is nice. It's close to 1.6, which is what's at 8/5. Both of these will come back to both of those values again in a minute. So there's one solution for you. I'm going to skip the next one, which asks you to find golden ratio lengths in a pentagon, or a pentagon with a 5-point star inside of it. By all means, there are tons of them in there. It's just kind of your job to go find them. Find 2 other places the golden ratio occurs, one in nature and then one in human-generated form. These 2 right here actually are one example of that. You might not really like they're a fraction. What's a fraction have to do with anything? If you ever buy photo prints, 2 of the most common sizes that are bought, I'm looking at some right now on my wall, are 3x5s and 5x8s. I'm looking at some over here on my wall too. 5x8 and 3x5. Why those sizes? You ever stop and ask yourself, why would you make a 3x5 or a 5x8? And the answer I've always been given, and this is where art and math kind of commingle, is that it's an aesthetically pleasing dimension for a rectangle. In other words, you look at it, and I'm looking at a 5x8 picture of my wife and my son over here and up there at the beach, and I'm looking at one over here that I trimmed down, and it's funny. It looks too skinny. It's too long. It's not. Here, let me show you. It's So here's a 5x8 and a 5x8, and here's a, I'm not sure what that is, but it's too skinny, compared to the other 2. And I think that the reason is that, and this is, again, we're getting artsy and not really mathy here, the golden ratio proportions for a rectangle look more correct to the human eye. They're just the right amount of height with length, not too much, not too little. Again, you can't quantify that. It's a feeling more than anything. Regardless. So one place is pictures, 3x5s and 5x8s. So another solution for you. As far as nature, go find your own. The Fibonacci Series 1, I typed that wrong. I'm going to go back and fix that. It should be 1, 1, 2, 3, 5. If you're watching this video after January 29th, 2014, it will be fixed. But the Fibonacci Series goes 1, 1, 2, 3, 5, and the characteristic of the series with it, the generator of it, is that each element after the third one, including the third one, is the sum of the previous 2. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 and 5 is 8, 5 and 8 is 13, 8 and 13 is 21, and so forth and so on. It's going to be 34, 55, and it goes on forever, dot, dot, dot. The question is, what is the relationship of Fibonacci with phi, with the golden section, or the golden ratio? And you'll probably look. There's only one real result from this. If you look at the ratio of successive terms, 1 to 1, 2 to 1, 3 to 2, 5 to 3, 8 to 5, 13 to 8. You may have noticed these before up there. These numbers get closer and closer in value to that decimal. And you can prove it mathematically if you let this go out infinitely. Like if you take the nth Fibonacci number plus the next Fibonacci number, and you get the n plus 2th Fibonacci number, the ratio of these guys has to be phi as n goes off to infinity. So the idea is that these ratios successively get closer and closer to the golden ratio phi. So, at any rate, there's some solutions for you, not all of them obviously, because some of them require some Googling. But it's a really interesting topic. It shows up in interesting places. You'll see some as you do your research. But pretty fun stuff. One of those neat blends between mathematics and art, even music. Maybe you found that one in your Googling. But at any rate, hope you enjoy it. Tool fans, I believe Fibonacci Series shows up in a Tool song. Just learned that last night. Never really got into those guys. No disrespect, Tool. I think you guys are amazingly talented. Just can't really listen to their music. Anyway, hope that helped, and see you in class.